All right, let's get to it. So sorry, first of all, that this is a very late video. I was moving, so craziness happens. But yeah, welcome to the first video. So what are we going to do in the video? Well, we are going to continue on with everything that we spoke about in our last class. And we talked about data and what is data and how do we use it, right? So a sample of data was something that looked like this, right? So if I went here, we see that this is raw data. We are asked for their gender, birth year, birthplace, first generation, continues on, right? And we classified our data between two different variables, right? So we said that we had variables. Whoops, that's not it. We had variables, and we were able to categorize these two variables as either numerical variables or categorical variables. Okay, so if I went back to the gender variable, we said that this is going to be categorical, right? Because this is a category, right? You can't really express this as a particular number. Whereas shoe size, this one will not be a category. This is going to be more of a numerical value, you know? So yeah. So this is what we have. We have our data. We started off with identifying a research question. Then we asked our survey. We had our population take I'm sorry, not the population. We had our population. We sampled from the population, and now this is our sample that we got based on our survey that we gave out. And now what we want to do is, well, what do we do with this, right? Exactly. So the first thing that we want to be able to do is organize your data, right? Organize it in a way that you can go ahead and visually see what is going on with the height, what is going on with the first generation, what is going on with shoe size, right? That's the first thing that you kind of want to do. And the way that we're going to do it is by graphing it. So we're going to look at a couple graphs, right? So for numerical, these are the graphs that we're going to look at. We're going to look at dot plots. We are also going to look at stem plots. And the last is going to be histograms. Okay, and for categorical variables, we are going to look at bar graphs. And we are also going to look at pie charts. Okay. What we've already kind of talked about some of the categorical variables and how we can visually see it. And we did it in class via a contingency table. Right? So if you forgot what a contingency table was, maybe look over your notes, right? But basically the contingency table was we said that it was a two-way table, right? You had males and females, I forgot what it was. And then if they have a pink shirt, right? Yes. Or if they had a no pink shirt, then we had no. And it was a good way to visualize these two different variables, right? In a sort of table. But what we're really going to be looking at is just these graphs, being able to graph them, right? If I know that I have a numerical variable, what is it going to look like? And if I know I'm going to have a categorical variable, what is it going to look like? Okay, so there's a keyword that you need to know, and that is distribution of a sample. So the distribution is a way, let's just write it, a way to organize data. Okay, a way to organize data. This worksheet is, or this sample, how do you say it, paper, whatever, PDF, is available on Blackboard. So if you want to go ahead and write on this, you can, or if you want to take your own notes, you can also. So distribution of a sample is just a way to organize our data, and the way that we're going to do it, we're going to look at it graphically. Okay. That's the first thing. Okay, so the first step, well, many ways to represent the numerical data. One way is by dot plots, right? And the way that we do it, and dot plots are really useful when you have really small samples. So if you have a very small sample, right? If you have a small sample, ooh, this is cute color. Small sample. Okay. Ooh, all right. Okay. I didn't know that. All right. So, when you have small samples, you kind of want to use a dot plot because it's really easy to see and it won't be too cluttered. So in this case, we were looking at patient satisfaction, and and then the number of observations. So, for example, who thought, who was not very satisfied, so not satisfied. Okay, and this was very satisfied. Okay. And then everything in between is just if you were somewhat satisfied or not. And what you can see is that if you were to go ahead and go back to the data, right, what you'll see in this particular data set, you'll see a 0, a 1, or anything else. So you'll probably just be seeing numbers that look like this, right? And it's really hard to go ahead and look at them. So one way that we can do it, I don't know what happened, but anyways, okay. Something happened on my end, so hopefully nothing happened on your end. But what I put here, okay, so dot plots, levels of satisfaction, right? Number of observations, right? So here are my number of observations, and then level of satisfaction. So you can count them. 4 people were on the 2 scale, right? Here, 2 people were not very satisfied. And then here, 3 people were, no, not 3 people. 1, 2, 3, 4, 5, 6, 7, 8, 9 people were around in the middle. So we can kind of count. And this is actually a really good way to just visually see what the graph looks like. And it's much easier to see as opposed to just looking at the column. So that's one way, right? A dot plot. The next one is a stem plot, right? So what I did here, I wrote down sample scores from an exam. So once you have all of these scores, right, you can go ahead and organize them as a dot plot if you'd like to. But another way that you can go ahead and do it is via stem plot. So a stem plot, basically what it is, it separates it into 2 different categories, okay? And the way that we do it is we look first at the leftmost digit, right? So like, for example, this one's a 4, right? And we're going to go ahead and write them on the left-hand side. So here we have a 4, right? We also have a 6, right? We have a 7. What else do we have? We have an 8, a 9. Do we have a 5? I don't think we have a 5, but we're still going to put a 5 there, right? So this one, this side is going to be my my leftmost digit, right? And I'm going to go ahead and write it on the left. Do a line, and then on this side is going to be everything else that's all the way to the right. So in this case, how many what numbers start with the 4? So in this case, it will be a 40. This is basically the only number, so it's going to be 46. So we're going to write the ones digit over here. Okay, and then there's no more 4s. Then for 5, you can see that there's nothing here, right? So we're going to leave that blank. 6, well, is there any 60s? Okay, so we have a 67 and we also have a 68. Okay, so this means that you have 67. This means you have 68. So then we're good with this. 70, so well, we have a 71. We have a 72. We have another 72, so I'm going to write another 2. We have a 74, 5, and 7, right? So that's what we have. And then an 8, right? We have a 1, a 4, a 5, a 9, and then for a 9 we have a 3, a 4, and a 5. Okay, so if you kind of look at it on your right hand, so if you kind of tilt your head, you will kind of see like this type of distribution. You kind of see like, I don't know, some sort of belt-shaped curve, right? So, and this is kind of what we're looking for. We're looking for some sort of shape that we can gather from the data, right? So these are 2 different types of plots that we can use, right, to look at numerical data: dot plots and stem plots. Stem plots also are good for small samples, right? So if we have also a small sample, right, a stem plot, oops, that's not how you spell small sample, then you can go ahead and represent them with stem plots and dot plots if we'd like. But also if you have whole numbers, if you notice that here the numbers are whole, it's much easier to represent stem plots with those with numbers that are whole numbers. But what about if we have numerical data that is like weight, for example, or height, or GPA, right? Well, in that case, right, something that we can also use is histograms, right? So histograms, right, are just grouped into bins, right? And the bars are represented with how many observations are there. So for example, this is number of shoes, right? So the number of shoes that males and females were. That's what if you go back to the data set, that's what it was. And basically all it is, it groups them into bins, right? So here from 0 to 10 shoes, right? How many people have from 0 to 10 shoes? Well, in this case, right, if we go all the way up, I think in this case it was 18, right? I'm not sure what it was, but I think this ends at 18. But this will tell me the height of the box will tell you how many observations are there, right? That gives you the frequency of it. Okay, and then you can keep going, right? From here, how many people wore like from 60 to 70 shoes? Well, I think there was only one person in this case, right? So, and it's really below 5, so it's probably just one person had shoes that were between 60 to 70. Okay, so this is just frequency, just regular, how many observations, right? Whereas here is the same exact shape, right? It's the same histogram. The only thing that we do it in relative frequency, okay? And what relative frequency is, you take the total number of people that responded, right, and divide it by whatever this was, right? So in this case, we had 18 people, right? And then you divide it by the total. I think the total is 53 or 54. I'm not sure. Divided by 53, right? When you go ahead and divide this out, you get a number between 0.3 and 0.35, right? So I don't know what it was. I think it's maybe 0.34 or something like that. Okay, but that's what we have. So it's exactly the same histogram. It's just the y-axis is in a different unit, whereas this was observations, this was relative frequency. Okay, so I'll stop here, and in the next one we'll do examples using these graphs.